Okay, hi. Uh, Today we're going to be doing a practice question for vectors, and this is a tricky one, so we'll just go through it. And yeah. Okay, so question 13. Consider a triangle OAB where the midpoints of the sides are x, y, and z as shown. OX, AY, and BZ are called the medians of a triangle. Okay, so this is a classic IB exam question. This question is trying to lead you into doing a proof. Whereas, usually in a lot of cases, you have to do the proof without any prerequisite questions. But anyways, this is a pretty simple question. It's a pretty good guiding question, and it could be pretty reasonable to ask on a paper 3. Anywho, yeah, so let's start with question A. So A is write OX and BZ in terms of A and B. So, this entire thing here, that's A, and this entire thing here, that's B. So if we want to write OX, that's just the median of A and B. So OX is just OA plus OB over 2. Then that equals to A plus B over 2. Next, if we want to find BZ, we want to find this. So that would be BA plus BO divided by 2, because then that leads to this median. So BZ equals BA plus BO over 2. So that's just, well, BA is just A minus B. And then BO is negative B. Then you divide that by 2. And that just gives us A minus 2B over 2. So that's A. Next is B. So B, suppose OX and BZ intersect at P. Write OP in terms of A and B. So this is what the diagram is showing. The intersection of P when you cross these lines together. So here's how to do this. You should make two vector equations based on OX and BZ, given a magnitude or position vector and a direction. Same with BZ here. So let's just call this here line, capital L, line 1, and let's call this line 2. So our line 1 is equal to the position vector that OX starts at, which is just 0. So we don't even have to put it, but I'll put it here anyway. So the 0 vector, which is just 0, so you don't even need to put it. And then plus the direction of OX. So we know the direction of OX. It's just A plus B over 2. So A plus B over 2 times the parameter. So the parameter implies that this line can go as long as you want based on the value of t. Next is BZ. So BZ is a little trickier because the position vector this time is just B, and the direction is in BZ. So it actually does have a position vector in this case. So line 2 is equal to the position vector for B, so that's just OB, or also just B, plus the direction of BZ over 2, or times t. So A minus 2B over 2 multiplied by t. So these are our two lines. So our p-value is when you combine these, like when you equate these lines to each other and solve for t. So let's just equate them, right? So if we equate these to each other, that's just A plus B over 2t is equal to B plus A minus 2B over 2t. Okay, so let's get the t's all together, combine like terms. So that gives us 3b over 2 t equals b. Okay, so the b's cancel in this case, and then if you divide both sides by 3 over 2, you get t is equal to 2 over 3. So this means that if you plug in the value of 2 over 3 to either of those lines, you should get the point for p. So let's just do line 1 because it's simpler. So the position vector of p would be equal to a plus b over 2 times 2 over 3. And that's just 2's cancel, a plus b over 3. So that's question B. And now for C, C says write YP and PA in terms of A and B. So what is YP? Well, YP is this. And then PA this is PA. One second, let me just make this sort of straight. There we go. Okay. So let's start with YP. So YP is just OP minus OY. And if you look at OY is just the midpoint of OB. So if you want to find the midpoint of OB, that's just B over 2 because it's half the length. It's half the magnitude of B, but in the same direction. So it's B over 2. So that would be A plus B over 3 minus B over 2. So if we multiply, if we get both sides to the common denominator, that is a factor by 2. So times 2 times 3. We get 2a minus b over 3. So that's our value for YP. And then we want to find PA. PA is simple because we know both values of OA and OP. So that's just OA minus OP, which is just A minus A plus B over 3. And that just gives us, let's see, 2A minus B over 3. Also, sorry about this. This should be a 6. So one interesting property of both of these is that we just proved that YP is half the length of PA. And it visibly looks like this, right? So, yeah. So anyways, those are our two values and D. Let's do question D. So D is a proof question. So show that the medians of a triangle meet at a common point. So what does this mean? We want to show that, let's just do this in a different color. If we have this line here, and we have this line here, and then you also have this line here. You want to show that all of these three lines meet at P for this triangle specifically. So how do we do this? Well, we give all of these lines vector equations. So let's call this L1. Let's call this one L2, both all lowercase l. And let's call this one here L3. So we want to equate these two not all together, but two at a time, 3 times. So we want to show that all of these would meet at point P. So here's the thing. Line 1, the position vector is y, or OY, and that's just b over 2. And the direction, well, the direction can just be yp. So question D here, our first line is equal to, for simplicity's sake, let's just subtract OA from OY. So plus YAT, and that's really just b over 2. What's YA? Well, that's just A minus OY, which is b over 2. We can really just simplify this. So 2a minus b over 2t, that's our first line. And then let's do this on the same line. So line 2, let's see, what is our line 2? This is our line 2, so the position vector is OZ, and that's just a over 2, because that's the midpoint of OA, so half the magnitude. And the direction is ZB, so that's negative BZ. So we can find this pretty easily. So that's just it's a bad B. T. So all of these have the same parameter. One second, let me just, yeah, okay. So that's A over 2 plus ZB, which is negative BZ. Where's BZ? So that's 2B minus A over 2. Times T. Okay, so finally, line 3. If we look at line 3 right here, that's the position vector for x, so OX, in the direction of XO. So that would just be OX minus XO times T. So we know that OX is just A plus B over 2. And we're taking the negative of OX, which is XO. So negative A minus B over 2 times T. So I should probably state the simple one before I put that down. So OX plus XOT, which is equal to this. So what do we want to do here? Well, we want to equate all of these lines to each other. So we want to do line 1 with line 2, line 1 with line 3, and finally line 2 with line 3. So why do we want to do this? Well, we want to show that between every single line lies a point, and that point is the same value for each of these intersections. So that's how to prove this. So, okay. First, we start with line 1 with line 2. Let me just maybe I should put D up there so I can just do everything up there. Then I can do the dotted line. Okay. So starting with line 1 with line 2, we just equate the two. So b over 2 plus 2a minus b over 2t is equal to a over 2 plus 2b minus a over 2t. So combine like terms, and yeah. So let's see. Well, that gives you a factor of 3. So 3a minus b over 2 times t is equal to a minus b over 2. So what can you cancel out here? Well, 2 is in the denominator for both, so you can cancel that out. And this is present in both, so you can also cancel that out. So what we're left with is 3t equals 1. So to solve for t, we would just divide both sides by 3. So t is equal to 1/3. So what we're trying to prove here is that t equals 1/3 when you do the rest of the intersections. So next is line 1 with line 3. So that's just b over 2 plus 2a minus b over 2. What's our line 3? A plus b over 2. Negative a minus b over 2 times t. Okay, so if we equate these to each other... Oh, I forgot the t here. My bad. So just combine like terms again. Let's see here. 3a over 2 t is equal to a over 2. So canceling out the 2's, canceling out the a's because both are on the same side, and then divide both sides by 3, t is also 1/3. This is good because we're proving it. So now we do lines 2 and lines 3. So when we do lines 2 with lines 3, we just equate them once again. So a over 2 plus... That's equal to a plus b over 2 plus negative a minus b over 2 times t. Let's just make sure I got that right. Yeah. So just like the last two, combine like terms, and so that should be 3b over 2. Yeah, 3b over 2 times t is equal to b over 2. So these cancel out once again, and dividing both sides by 3, t is 1/3 once again. So what does this mean? That means all lines intersect at t equals 1/3. Therefore, they all have a common point. Okay, that was D. D is pretty long, it's a proof, but knowing how to do this is pretty useful. So yeah, that's the entire question. The skills that are required for this are really just basic understanding of midpoints and how to do basic vector arithmetic, and yeah, understanding of vector equations and all that. And yeah, that's basically it. So yeah, thank you for watching. I really hope this helped your understanding a little bit. And yeah, see you guys next time.